Hello and welcome back to the Programming in C++ Part 2 series. Today we're going to go over Programming Exercise 13-13. Before we get started, let's go ahead and smash the like button. Feel free to leave a comment, but most importantly, make sure you're subscribed to the channel. When you are subscribed to the channel, you do get updates whenever new videos are posted, and it helps you navigate YouTube a little easier. All right? And if you're unable to do any of that, it means you're not logged in. So to create a YouTube login account, it is free and it takes less than a minute. So make sure you do that so that you can communicate with other YouTubers and find your favorite videos a lot easier. All right, so let's dive into exercise 13-13. And here we're going to design a class to perform various matrix operations. A matrix is a set of numbers arranged in rows and columns. Therefore, every element of a matrix has a row position and a column position. If A is a matrix of 5 columns and 6 columns, we say that the matrix is A, or matrix A is a size 5 by 6. Clearly, a convenient place to store a matrix is in a two-dimensional array. Two matrices can be added and subtracted if they have the same size. Suppose A equals Aij and B equals Bij. And are two matrices of the same size, M, asterisk n, in which Aij denotes the element of an A in the ith row and the jth column, and so on. The sum and difference of A and B are given by A plus B equals Aij plus Bij. A minus B equals Aij minus Bij. The multiplication of A and B, A times B, is defined only if the number of columns of A is the same as the number of columns of B. If A is of the size M times N, and B is the size N times T, then A times B equals C. Ik is of the size M times T, and the element Cik is given by the formula here below. Design and implement a class matrix type that can store a matrix of any size, overload operators plus, minus, and asterisk to perform the addition, subtraction, and multiplication operations respectively, and overload the operator to output a matrix. Also write a test program to test various operations on the matrices. Alright, and task 1 program produces the correct output. Alright, so let's see what we got here. And we're going to have to create our own header file and our implementation file. So just, like I said, if something goes on and we can't get it the first time, if we're unable to get it first time, there's a lot of room for error here, but I'll do my best. If not, check the comments and check the description if you get to the end and if it's not solved on the first shot. All right, so let's go ahead and start by creating our header file, and we'll call it matrix type.h. Oops. One off on the keyboard. And there we go. And let's go ahead and create our implementation file to matrix type .cpp. And looks good. Alright, so let's go to our header file first. Close that out. Let's close that out. And there we go. There's more room. So matrix type, first thing we're going to do is do our if and def. And we'll go capital H underscore matrix type. And then we'll do our define, pound define H matrix type underscore matrix type. Alright, and remember this area is going to remain until we get to our last line and close it out. So next, our include statement will just be IOStream. And then let's go down to using namespace std. And then let's do our class, and we'll call it matrix type. got that, and let's go ahead and do our brackets. So from here, let's take a quick break, and we'll return right after this. Alright, so let's go ahead and do our first line of this one of the O stream. So let's go with friend O stream ampersand operator. And remember we'll do O stream ampersand constructor matrix type ampersand. And then we'll do semicolon at the end of that. And let's go ahead and copy that. And we'll do the I stream. Change this to I stream. Change this to I stream. Change our symbols to opposite directions. And there we have it. Those two are complete. And let's go down to stay inside our brackets here. Let's go ahead to our public side, make sure there's no indent. Then let's go here, we're going to overload assignment operator. So let's do constructor matrix type ampersand. And let's do operator, and we'll use the equal sign matrix type. And let's call this time, let's do ampersand right. And let's go to semicolon. And I spelled that wrong. Get that corrected. And so let's go next to void set matrix. Let's go empty. And let's go matrix type. Let's go integer rows equals 10. So we got 10 rows. Integer columns equals 10. 10 rows, 10 columns. And this is going to be the default matrix size. Let's go and copy our constructor by matrix type. And we do same constructor matrix type. Constructor. So next, let's finish the rest of these. Let's do matrix operator plus and matrix type right. And semicolon. And let's copy and paste this matrix operator plus. Matrix type operator. And this is lowercase. There we go. Now let's copy this for the other signs 2 times. 1, 2, and we'll use minus and asterisk. No division needed in this one. So multiplication. And then let's go ahead and define our privates. Going to be integer, and let's do 2 asterisks matrix, and then integer row size, and then integer column size. And that's all we need, so let's go ahead and do our semicolon at the end of our bracket. And let's clear up this fault by using our pound and if. And that should clear up all the faults. Alright, so that's all we need for our header file. Let's run you through that one real quick so you can see everything. Please pause if you need to, if you need more time. But this is what we got. And everything looks good. Alright, go back up. And we'll close that one out and go ahead and open up our implementation file that we created. And it's blank, of course. So before we get started, let's take a quick break. We'll be right back after this. Okay, let's start by doing our header out with our include. So let's go include IOStream. And we're going to need IOmanip for this one, so let's go ahead and do that. And then our header file. It's going to be matrix type.h. There we go. And using namespace std. And then let's start with matrix type. I'm going to keep this in my back pocket so I can type it in a while. So let's go matrix type, colon, matrix type. And then we'll do integer rows, integer columns. Let's go down here, brackets, and let's do row size equals rows, and column size equals columns. Let's go matrix, and let's do that equals now, integer, asterisk, and let's use our array box to say row size. And let's semicolon there. So now, new. Sorry about that. And then we got 4 integer index equals 0. Index less than row size, and index plus plus. And there we go. And we go matrix index. We use the array box for that. And we'll say equals new integer, and this time column size is in the box. And that's what we need for there. And let's run another 4. 4 int I equals 0. I less than row size. I plus plus. We'll say another 4. We'll throw in there and say 4. J, integer j, equals 0. J less than column size. J plus plus. Matrix array I and an array j, and then we'll say that equals 0 semicolon. All right, so that's it for that function. Let's come on down to our next one. Let's do matrix type, which I copied. Matrix type again. Let's use constructor, matrix type copy, or ampersand copy. Just following along with my header file. So this is going to copy the constructor. Let's do our brackets, and let's go row size equals copy dot row size. semicolon, and then column size equals copy.column size. Matrix equals new asterisk integer, and let's go row size in the array box. Semicolon there, should clear that up. Oh, got it in the wrong order. Should be integer and then asterisk. Okay, there we go. And next, let's take a quick break. We'll be right back after this. Alright, so welcome back. So next, we're going to use this again, this whole for cluster from 14 to 19. So copy that. Let's go to 29 and paste it there. Let's get me a matrix type copied again. So we're going to use that next. Alright, so what I did, I added that for statement to close out this. One more thing I'm going to need on this one. Oh no, that's good. Let's go to our constructor. That looks good to go. Let's go constructor, matrix type, and then ampersand, matrix type, colon, and let's go operator equals. And then, oops, and constructor, matrix type, ampersand right. Then let's go brackets. And clear. So next, drop it down a little more. So next we got if this is not equal ampersand right. So this is going to avoid self-copying. So we got row size. We can do that again too. Let's go ahead and get that. Row size equals column size. And then we'll do our for. Just copy. Put that on 42. Row size equals right row size. Okay, I'm messing up here. Let's go back here. Space delete. There's right. Dot row size. Column size equals right dot column size. Alright, so we got that hiccup done. Let's go ahead and get this for going. And let's say for integer j. So I and j. So we'll do this one for integer I and j. And we'll beef this up at the end. So let's copy this one, 32 to 34. Fix it up though. Because matrix ij is not going to equal 0 this time. It's going to equal right dot matrix ij. And then semicolon. Alright, so then here, once we've done that, bring this up one, and then outside of this, after this if bracket, for this function, let's go return this, asterisk this, and semicolon. Alright, so that's it for that function. This matrix type again. So I need it. Actually, yeah. And let's go here. Some space. So let's go void matrix type set matrix after colon set matrix, and once again that's going to be empty according to the header file. Brackets there, and we'll see out this matrix has, and we'll use the variable row size and space rows and space going down to the next line. Oops. Continue. Column size. So we'll use a variable column size. Then we'll go space columns. No space there. Then we'll end line. Then we'll drop down and do count. Enter data for this matrix. Space, and then we'll end line, and we'll come down, and before we start our form, let's take a quick break. We'll be right back after this. Alright, so let's go ahead and get this, what these four, let's fix this as a matter of fact, this should be indented on 46. We'll get this again. This matrix should go over 2. So make sure 45, 46, 46, 47 is indented. And then we'll copy 45 and 46 and we'll type in. Actually, we'll go ahead and get this to the whole thing. Why not? Actually, let's delete this. Alright, so I just got matrix AJ, or I and J. Let's go here to line 59. Let's copy and make sure it lines up, and it did. Let's put a semicolon after matrix IJ, and actually we got to do CIN in front of it, and that'll take care of that. Function is complete. Let's go down to, let's get this matrix type again. Actually, yeah, let's get this matrix type. We'll do some typing, it won't hurt us. Could type another line, but let's go matrix type, and you'll see what I'm talking about when I say operator plus again, and then we got matrix type right. Right, so now let's go ahead and bracket. And we'll do matrix type temp. And let's do if row size is not equal right dot row size, or column size column size. Alright. So actually we're going to use brackets here again. And let's go temp.row size equals 0. And if temp.row size equals 0, temp.column size equals 0. Alright, and then let's see out. Cannot add different size matrices as per the instructions. outside this if bracket and do else. And let's do brackets of our own. And let's go temp row size equals row size. Temp dot row size equals row size, which means temp dot column size equals column size. Alright, if I'm going to P again. Okay. And let's do our good old 4 again. Let's go get it this time. And I'm just going to get a little more for the matrices, so we'll leave those out. And I'll take that one in already. So just make sure that we'll skip a space for the for statement. And there you go, good. So right underneath the second for statement, let's indent one. And let's say temp.matrix. I, J in an array box equals matrix I, J in array box plus right dot matrix I, J in array box. And that should be good to go. Alright, so one thing here, let's go ahead and move that space and go right up to this bracket. And let's space again and return temp. Right. And I need my matrix type. Where you at, matrix type? So we do. So copy that. And let's go down to our next function. We'll do that on 87. And let's go matrix type. See, yeah, we're gonna do that. We're gonna copy and paste these next two operators. So let's go here, matrix type operator. Let's do all this, all of it. Put in the bracket. 87. Boom. Let's change this to minus. And matrix type is good. Row size, this is not going to change. It's not going to change. It's not going to change. It's not going to change. The else statement, it's not going to change either. And these are going to remain the same as well. Temp matrix ij equals matrix ij minus. So just the two minuses. And then we're going to return temp. Let's return that right there. And let's go down to 9. Let's copy that again, and this time we're going to asterisk, and then remember, turn that to asterisk times. Alright, so it looks like we've got that licked, and I think this one, since it's multiplication, it needs to be, let's go, let's add one more line to that. So let's fix that. So for j equals 0, j plus plus, let's come down here for this 4, and let's go brackets. Let's go temp.matrix ij. Let's put this here. And we'll just copy it. We're going to need that again. This is going to equal 0. Semicolon. Then here, let's go chop that down. And just go tab over. Sorry about the tab over twice for that one. Plus we need our 4 here. And we'll say 4 integer k equals 0. And then k is going to be less than column size, and then k plus plus. Then we'll say temp.matrix ij plus equals matrix IK times right matrix KJ. That should make sense there. And so temp dot matrix IJ is off IK KJ. So that means for I equals 0, I less than temp row size. That's what I need here. Temp dot row size and temp dot column size. Alright, so there. And so it looks like one more is offline too. Let's see what we got. Temp dot row size, temp dot column size, J++. Temp matrix, IJ equals 0, nothing wrong with that. Print K equals 0, K column size, K++, temp dot matrix IJ plus equals matrix IK times right dot matrix KJ. Alright, and then we will return temp on that. Yes, we will, but we still have an issue with I and J. So let me check this out. Take a quick break. We'll be right back after this. Alright, so let's go back up to line 113 here. So we don't
go back right now.
We don't need these ORs. We don't need these ORs. All we need is on 113. We just need that. Column size is not equal to right dot row size. And temp 0, temp, oh, that's correct. So down here looks good. Temp column size equals right dot column size. Column size and temp row size equals row size. That's correct. So we're still as 122 under the operator, ampersand operator. And let's see, what do we shot in here? Down to 122, right size. Hit I, temp row size, I plus for integer j equals 0. J less than temp dot column size, j plus temp dot matrix ij equals 0. So for int k 0, k is less than column size and k plus and temp matrix ij plus equals matrix I k times right dot matrix kj. Alright, look. Oh, that's what I did. I didn't do my 4. This should be inside the bracket. Let's go here. Let's close the bracket out here. And there's define, because I had it outside the bracket. Now it's inside. And then return temp on that. Alright, so let's put you all on board. Let's go. Let's see. Now we got an overload stream insertion operator. So that's going to be our O stream. Let's see. O stream ampersand operator. O stream ampersand OS comma constructor matrix type, and then this time let's go ampersand match. So let's do brackets, and let's go and type these up. Yeah, let's type these up. 4 integer I equals 0, I less than mat dot row size, and I plus plus. Go. Down tab, brackets instead and do another 4, integer j equals 0, j is less than mat dot column size, and j plus plus. Okay, O is to 0, make sure you got the number 0, and column size need to be Kelvin. There we go. Here, tab, and let's go OS, set width, and we'll do 6, mat dot matrix with I and J arrays. Space between those, semicolon there. And let's go to our 4 in OS inline. Semicolon. And then in this one too, OS inline semicolon. Oops. And then this time let's return here, and we'll type this up. Let's go to the next function, which is going to be to overload the stream extraction operator, or the IS stream. Show everything here. Yeah, that's good. So yeah, let's go. Let's go I stream ampersand operator opposite direction. And let's go I stream ampersand IS comma and matrix type. And we'll call this ampersand empty. Here, brackets, you can see out, say this matrix has space, and we'll use the variable mt dot row size, and then let's go to space rows and space here, mt dot column size, and check those in my header file. So space column, and I thought the mt, that's what it's doing that, columns, and then let's go inline. Let's go cout, enter data for this matrix. Okay. Place that. Let's go inline. And let's go for integer I equals 0. I is less than mt dot row size I plus plus, and then left out my brackets. Yeah, when I have those errors, it bothers me, messes up my concentration. But nevertheless, for j, integer j, equals 0. J is less than mt column size j plus plus, and is mt dot matrix I j in the brackets t j, and let's go semicolon, and then let's return is, and that's all we need for that. But let's go ahead and check this header file. Leave that one open for now. Header file. Let's see if we got an NT at the end of this one. We didn't do that last one correctly. Let's see. Nope, it's gonna be in our main then. There's no need for that. For matrix type, ampersand. Matrix type. Inputs. MT type ampersand, same thing. Alright, so let's close it out. That looks good still. Let's take another look at this implementation. So let's take a quick break. We'll be right back after this. Alright, so yeah, I'm back. I did redo the header type. I didn't see anything, but I'm going to go ahead and show it to you. I couldn't tell what I did wrong. I just retyped it. But let's put this asterisk there. You know those faults cleared up. So let me show you this. Actually, let me show you the header type file again to make sure that if you see I missed something and whatever, I did retype it and I didn't see any difference. So here you go. Take a good look at it. Maybe you caught it the first time around, but I don't see what I did different. And that happens sometimes. I don't know. Everything looked like it's supposed to. But anyway, that's the header file. So it might be the exact same thing you have. Pause it if you need to get a closer look. And then my tip implementation file, here's what we get. We'll go from the top all the way to the bottom. Please pause if you need. And I'll give you a chance to look at this one all the way through. And if you wonder why we jumped to lesson or exercise 13-13, because 11 and 12 is not graded. They must be practices or not even in there. So I didn't bother to do those. If you have access to them and you want to do them, whether they're graded or not for practice, I recommend doing your graded stuff first and then going back to them. Unless you're ahead, then by all means, knock yourself out. Alright, so here's what we got on that implementation file. And there it's clean. So, right, so we're going to go back at the top. And then we'll jump on our main and close that out. Make sure I'm still in the game here. So put yes. Alright. So alright, so for our main, shouldn't have to do too much work on this one. So we got our R stream already there. Let's just include our header file, which is going to be matrix type. Let's copy that. And let's go. Matrix type.h. Points. Put this down a little bit. So we're going to do matrix type and matrix 1. And it's going to be 3, space 4, and semicolon. So what we got to do is copy this one 4 more times. 1, 2, 3, 4. Go ahead and change this to matrix 2. matrix type 3, matrix type 4, and matrix type 5. Okay, this is going to be, okay, so let's go matrix 1 dot set matrix, and we'll do the function. Alright, and let's copy this one 2 more times. And let's change this one to 2. And this one to 4. Alright, and then let's go. Let's see out. And let's go matrix 1, variable, and inline. See out. Matrix 2, and then inline, and see out. Matrix 4. Alright, next, let's do the math part. Let's do matrix 3 equals matrix 1 plus matrix 2. Okay, matrix 5 equals matrix 1 times matrix 4. And then see out matrix 3 and 9, and see out matrix 5 and 9. And then we're going to return 0. It's up here. So, alright, so let's show you this code. If you need to pause it, please do so. But here we go. Actually, let's fix these. So let's make this 4 and 2, matrix 4. And this one will be 3 and 2, matrix 5. Alright. So let's do that again so you can see it. 1, 2, 4, set matrix, matrix 3, equals 1 plus 2, matrix 5 equals 1 times 4. 3, 5 in line, and there you go. So let's go to our companion and try to run it. See what we get. Okay, enter data for host matrix has 3 rows. E. What we're supposed to enter here. What is this? So 4 minus 2. There we go. Yes. All right, so let's go ahead and calculate it. Hopefully we got that correct. All right, let that spin. Didn't see anything that should mess it up. So I had to do all the operators, minus, plus, and multiplication. So let's try that again. Enter data for the matrix. What it need to do. But I'll check these files real quick. Nothing. on that one either. And nothing going on there. So, yep, looks like we're going to hang with that. If we get a solution to that one then later, we'll post it. We just need to get the instructions again. So we got shear 0 on that. So let's see, A plus B equals 6. Let's try this then. Fine. So which is 3 has 3 rows, 4 columns, which is supposed to be that. 380s and 390s. I think it's the program's right. I'm just not doing the right, not understanding what they're asking me to do. Let's try different things. Right. 80, 90, 90, 90. I don't think that's what they wanted me to do. 6, 6, 6, 5, 5, 5. Messing up. Alright, let's try that. Yeah. If you solve the numbers, I think it's just me putting the right input into that part. Still not making too much sense to me. One shot. If not, like I said, check the, if that doesn't solve it, just check the comments and the description, and I'll have those put in there. The solution if we can't get it, and we didn't. So, but thanks for joining. We'll see you on the next one.